What do the two lines with the same slope and the same intercept do when it rains? They coincide. Get it? They coincide, they go inside. Anyway, so let's go ahead and talk about different types of line pairs based on the equations of lines, the slopes and the y-intercepts. So to determine the relationships between pairs of lines, make sure that the line is in slope-intercept form. That is, it should look like y equals mx plus b. And this is on your math chart as we discussed last time. So to find the slope, find the slope, which is m, and the y-intercept, which is b, for each line. Here are some parallel lines, and I'm going to just show you what happens to the slope. First of all, I can move this line up and down, so it's actually exactly the same line. If I slide it down, then the distance between B and C will be the same as the distance between A and D. Remember, the distance between two parallel lines never changes. As you can see, the equations for the lines show the same slope. So let me move this down just a touch further. Okay, and so I have different y-intercepts. So these lines are parallel, but different y-intercepts. Now I can play with the slope. I'm going to make a little fractional here. And you can see as I made the line shallower, the slope became smaller, but it was the same for both of them because both lines stay parallel. If I make the slope more steep, then both lines still have the same slope. You can also see what happens to the y-intercepts a little bit as I make the slope shallower and steeper. Now let's look at rotating a line that's already graphed. I'm going to take a very simple example that goes for the origin. The origin is 0, 0. And see what happens if I rotate it 90 degrees. So I'm going to rotate this line around the origin by 90 degrees. And you can see that it actually makes a right angle. So if I mark angle here, let's say here to here, you can see there's the 90-degree angle. Now, let's say I took this point, B, and looked at how it rotated about A by 90 degrees. Where does it go? It goes here to B prime. So initially, the coordinates for this are 4, 1. So let me go ahead and get my pen. 4, 1. All right? And then what are the coordinates for the other point? Yeah, let me see if I can. 4, 1. 1. And here the points are -1, 4. What happened? It looks like the x and y switched. X and y switched. And if you looked at the slopes, all right, let's take a look at that. So here we have the rise and run for this one. The rise is 1 and the run is 4. So m equals 1/4. And it's positive. For this one, the rise is negative. It's dropping down 4 and it goes over 1. So it's -4/1. If you flip them or take the reciprocal, you can see you get the other one. Flipping 1/4 gives you 4/1. Flipping 4/1 gives you 1/4. The only difference is that the signs are changed so that we have -4/1 here and 1/4. This is negative going down and this is positive. Why is that? Okay, so now I cleared up my line from the writing. So let's take a look at this. Are we always going to have one slope be negative and one slope be positive? So let's go ahead, I'm going to bring this point down. You can see how it kind of matches there. By the way, the cool thing is if I move this out to 6, that moves to 6. If I move into 2, see the rotation. Anyways, so I have it straight up and down. All right, this is a vertical undefined slope, and this is a horizontal or 0 slope. If I make this slope just a teensy bit negative, right? This is just a teensy bit negative. What happens to this slope? It's a teensy bit. Well, it's a lot positive, actually. It's not even a teensy bit. It's very positive. Here, let me make it a little smaller so it'll fit on the screen. Here it is. It's a little negative, and this is positive. So if I keep going, I keep it negative, 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 negative until it's vertical, then that one's flat. So when this one's undefined, that one is 0. Then let's say I make this a little positive. That makes the other line negative. So you can never have two perpendicular lines with both positive slope. You can never have two perpendicular lines with both negative slope. And they can't both be flat, and they can't both be undefined. So if one is vertical, the other is horizontal. If one is negative, like this one, the other one has to be positive. So after we played with the video where we had the slopes and things, let's talk about some of the different pairs. We already talked about parallel lines. Those have the same slope and different y-intercepts. Remember that the slope stayed the same even when I slid the line up and down. So parallel lines, the slopes always matched. All right? Intersecting lines have different slopes. So they may or may not be perpendicular. Perpendicular is a special type of intersecting line, and that is when it's a negative reciprocal. The negative means change sign, and the reciprocal is like the flip when you flip the fractions. Coinciding lines are really the same line. They have the same slope and the same y-intercept, so they're right on top of each other. So let's go ahead and look at some examples and see if we can classify these lines. The first step we're going to do is look at the slope. Now here, it was pretty easy because they were already in slope-intercept form. See, there's the 3 in front of the x. The y is on one side by itself. This one has a slope of 3 and a y-intercept of 7. This one has a slope of negative 3 and a y-intercept of negative 4. The slopes are different, but they're not perpendicular because to be perpendicular, you would need it to be the reciprocal, so the negative reciprocal. So instead of negative 3, it would have had to have been negative 1/3 to be perpendicular. All right, but it's not. So in that case, these are just intersecting lines. In the next set of problems, let's go ahead. One of the slopes, we're going to take this line here. We'll do the hard part first. And we're going to put it in slope-intercept form. So it's almost there. The y's on one side and everything else is on the other. But I need to make that 1y. So I divide everything by 6. You are actually allowed to divide each individual item by 6, and that will work out just fine. So negative 2 over 6 is negative 1/3, and 12 over 6 is 2. Then you can see that the slope for both of these lines are the same, but the y-intercepts are different. Since it is the same slope, but different y-intercepts, these are parallel lines. Then in this set, I need to rearrange both. So we'll start with the top one. I have x with the y, so I need to move that over. By the way, this is called standard form. Both of these are in standard form right now, which honestly isn't very helpful. We almost always want slope-intercept form. So I subtract x from both sides, and I say negative 3y equals negative x plus 6. Then I divide everything by negative 3, so I can make that 1y, and you can see the slope is 1/3. For the other one, I do the same thing. I move the negative 3x, take away negative 3x from both sides, really should say. Subtract 3x from both sides. And you find out right away that the slope is negative 3. Well, and the y-intercepts are 2. Now, actually, the y-intercepts aren't going to matter much here. It only matters for parallel to determine if it's parallel or coinciding. Now, if we look at these two slopes, negative 3 and 1/3, they are different signs from each other, which means they are the negative of each other. Negative of a negative is positive, and negative of a positive is negative. All right? Did I confuse you? I hope not. So they're different signs. That's the main thing. And if you look at 3, if you flip it, there's an unwritten 1 under here. 3 over 1 becomes 1/3, and they are opposite. So they're negative reciprocal slopes, which means they are perpendicular. In this last example, I need to make sure both of these are in slope-intercept form. So first one we'll take is I need to move the add 4x to both sides because x is over here on the y side, and then divide everything by 2. And I can see that the slope is 2. This one, I'll go ahead and apply the distributive property, where I go 2 times x is 2x, and 2 times minus 1 is minus 2. Then I add 10 to both sides, and I find out that the slope, this line is y equals 2x plus 8. They have the same slopes and the same y-intercept. So if they have that, these are called coinciding lines. They're really the same line.